In this episode of Coding in Motion, we're going to build another complete event system from scratch. This time we're using Python, along with Kafka, KSQL, and my phone to answer a simple question. How do you subscribe to alerts from another system when they don't have an alerts API? If there's something on the internet you want to keep tabs on and be alerted when it changes, how can we make a computer do that work for us? And this is going to be a fairly generic reusable recipe, but let's make it concrete. There are a couple of things that interest me personally that I would like to keep tabs on. An obvious one is certain musical instrument shops occasionally have sales on some synthesizers I'm interested in. I'd like to know when the price drops and get an alert. But I think the one we'll build with to start is, I've spoken at some conferences and there have been recordings and they've put it up on YouTube. And I'd quite like to know if anyone comments on those talks so I can reply. The problem is, I don't own the video. The conference owns the video and it's on their channel. So YouTube isn't going to tell me when there's a new comment. So I think that's quite a good concrete example of something we can subscribe to that the end system hasn't thought of. Let's build something, in the first instance, to track changes to someone else's YouTube video. So we start with a completely empty directory, and I'm going to create a virtual environment because this is Python. It's nice to have a localized place where we keep all this project's packages so it doesn't pollute any other projects. And I'm going to activate that virtual environment by saying source env bin activate, and then I will edit a file called youtubewatcher.py. Then standard preamble for Python, user bin env python. If the name under which this was invoked is that, then we are being invoked as a script. So I want to call the main function, which I will define soon. I quite like wrapping that in sys.exit so that this exit code is the script's exit code. And I also these days like to set up basic config when I'm just getting started with a logging level of debug. And then if I say here logging.info start, that should be a really bare bones Python script. Let's import that and that. Yeah, so back over here, chmod user plus x YouTube watcher, start. Okay, that is an absolute basic Python scratch file to work with. So let's just think a second about how this is going to work. I could write it so that it watches specific YouTube videos and alerts every time there's a change to those statistics. The problem with doing it that way, even though it's the easiest way, is every time I want to watch a new video, I'm going to need to update a configuration file and probably redeploy this script to wherever it's running, which isn't ideal. What I'd rather do is have a way of adding new videos in automatically and having the script just magically pick them up. And there's an easy way to do that. I can create a playlist of things I want to watch on YouTube. And every time I want to watch a new video, I can just add it to that playlist. And if this script is watching playlists and using that to drive the ultimate query, then it should all hang together. So this is my strategy for the code. Look up some playlists, see which videos are on there. Look up the videos, check their statistics, and just stream that stuff up to Kafka and deal with it there. So let's do that. Let's start by taking a look at YouTube's API. They have this cool playlist items. Give it a playlist ID. It will return all the videos in that playlist under here. So let's take that URL and say, I would like to use the requests library to get this URL. There will be some parameters to this, and I pass it a dictionary. We'll fill that in as we go, and that will give me a response. And then I'll just for now say logging.debug got that response text. I need to import requests. And then if I go to the terminal and run that, I get permission denied. Fair enough, Google needs an API key. Okay, let's create a config file. There are 1,000,001 different config file formats. For this, to keep things simple, I'm just going to use a Python file with a Python dictionary in it. And I'm going to give it the key Google API key, and I'll fill that in a second. So I want to grab that from a config like that. And then if I import that from the Python file config, import the object config. That should do that. And then I need to supply that to my web query as the key. If I stick a comma there, the auto formatting will be a bit nicer. Yeah, okay. So I need that Google API key. I am going to go and get that magically off screen because I've got one already. If you want to get one, just go to developer.google.com and you can find your way through there. You'll need a Google account, but it's easy to do. And if you're using this recipe for a different data source, you'll probably need an API key from whoever that is. So give me 1 second. I have something in my copy and paste buffer. There we go. A little bit of magic. Let's do some auto formatting stuff there. That's nicer. Okay, that looks about right. Let's see how she runs. No filter selected, expected one of playlist ID. Okay, so we've got past the API key hoop, and now we need to actually give it a playlist we're interested in. Well, I've already got a playlist ID I'm interested in. It's a list I've been curating for a while. It's some of my conference talks. If someone asks a question on one of these, I'd like to know, I'd like to reply, but the conference owns the video, not me. So this is what we're going to start off automating. All I need is this playlist ID, and I'm going to stick it into my config file as YouTube playlist ID. Like that. Okay, same dance over here. Config that, like that. And then I think I can say playlist ID is that. Let's run that. Yeah, that's looking more convincing, isn't it? So this response has an item field, and that's a list of things in the playlist, the videos. It's a bit threadbare at this stage, and there's a reason for that. We'll fix it in a second, but you also want to look at the page info field. Total results 12, results per page 5. Google is paging this API. It's only giving us the first chunk, and we're going to need to deal with that too. Let's start by fleshing out these items, because that's easy. You need to add a part field to the request parameters, and you can request a comma-separated list of parts. The only one I want is the content details, it's called, and that gives you a particular bunch of extra fields about each item. And if I rerun that, there we go. So each item has a content details field, and that's the video ID. That's the thing I'm really looking for to drive my final query. But before we leave this query, we need to think about paging. Google is breaking up the complete list of results into pages, 5 results per page, and we need the whole thing. There are a couple of ways to unpage this. We could do it the hacky way, which is to request a higher max results per page limit. I think the limit is 50. You can get up to 50 results per page. That would be a short-term fix. There's a better way to do it in Python, and I think it's an interesting way. So that's the way we're going to actually solve this. We're going to use Python generators. What's a Python generator? It's actually a lot like an event stream, to my way of thinking, in Kafka. You have some kind of thing which generates pieces of data, and you just want to sort of treat it as this infinite stream, potentially infinite stream of stuff you can deal with. Generators in Python, streams in Kafka, very similar ideas. So let's code that up, and we'll see how we can use a generator to magically unpage this code. First, let's make a function that can pull out a specific page from the API. I'll take that code and make it its own function. I will call it fetch playlist items page. It will need those two things as parameters. And now's probably a good time to do some JSON parsing too. So let's say that the payload from fetching a page is the result of calling JSON.load as a string, the response text. Then I will keep the logging for now, but I'll also return the payload. So that's returning a structured Python object instead of just dumping some raw strings to the screen. That needs an import. Okay, this should be, oh, make sure I call it. This should be the same code as before. Slight difference in the output because it's no longer printing a raw JSON string, it's printing the structured Python object, but that's essentially the same code. So let's modify this so we can get a specific page. So have a look here, you see this next page token? I need to be able to supply that to get page 2 and 3 and 4. So let's take that, and what I'd like to be able to do is something like that. Supply a different page token, get a different page. So let's say page token coming in here, if I can type it. We'll give that a default value of none, so I don't have to supply one, and that should give me the first page every time. And Google's API wants me to supply a page token parameter with that. So let's see if that works. Last video was published at 2:21, so we should get a different result there. Yep, that's 7:22, so that's a different page. Okay, we have a paging function. I'm just going to double check it still works to return the first page, as I'd hoped. Yeah, 2:21. Okay, so that works. How do I turn a page function into a every page function? How do I unpage? What I really wish I could do is say, don't think about paging at all at the top level. I want to hide that detail. So I wish I could take all my video items just like that without thinking about paging. Let's define the function that hides paging details for us, and we can build it out. Fetch playlist items. That needs to fetch one page. Serve up the items from that page. Then, if there's another page, carry on from there. That would do it. It would be nice if we could execute that code as is, but not yet. Check back in the 22nd century. Programming might have evolved by then. In the meantime, fetch one page is easy. We've already written that code. Our payload is fetch playlist items page. Once you've done that, we need to serve up those items. This is where generators come in. So generators are a really nice thing in Python. You also get them in JavaScript, they're in Haskell, they're probably in quite a few languages by now. And I think, in a way, they're also in Kafka. It's a very similar idea. I have a way of generating information, a bit like a list, but it's potentially infinite, and it's just coming in as and when. I'm going to serve you up what I've got so far. If you keep asking, I'll keep trying to generate more stuff for you to read from. So that's what we're going to use. We are going to take the payload's items, and we're going to serve those up to the caller by saying yield from that list. That's going to take the list and say, here's one, here's one, here's one, here's one. Oh, are you still asking? I'll try and get some more. So by the time we get to this point in the code, we need to see if there's another page, if we can carry on and serve up some more. So let's have a look for a next page token, which will come from the payload's next page token, being very careful between Python's snake case and Google's camel case. If there is a next page token, if it's not none, carry on from there. So we need to do a recursive call like this, and pass that the next page token. and that's where we'll continue yielding from. That now becomes the source of looking for new items. I'm slipping into Kafka parlance. To make that recursive call work, we need to go up here and allow you to pass in a page token for the recursion's sake, but for the top level user's sake, we want to default that out so they don't have to supply a page token. That gives us the thing we can supply to fetch playlist items page. So let's recap what this function does. You call fetch playlist items. You might give it a page token, you might not. If you don't, we're starting from the first page. We call the sub function which fetches the specific page, spit out all the items it gives us, and if the caller still wants more, then we'll look for a next page token, and if there is one, we recur and yield from there, spit out items from that function call. If we do that, and I change this into a for loop, which tries to log the items, got a video item, then that ought to work. That ought to unpage things. Let's see. Let me run that. It's definitely busier. It has crashed on a key error for next page token. I know why that is. That is because on the final page there isn't a next page token. So I need to make this lookup optional. I like the fact that payload items crashes for this particular piece of code. If items disappears, something's changed on YouTube's API. We probably should crash. But the lookup for next page token should return none if it's not there. So I can do that by switching to a part of the dictionary API. I can just call get. With that, let's see. Definitely something kind of right. Let me change the logging level. I think it will become clearer. Run that. Yeah, that looks to me convincingly like we've got 12 different video items. That's a generator. It lets us lazily load in the items from the paging API, and it lets us treat this whole thing like one single page, regardless of what Google's doing to optimize their delivery. Nice. With that in hand, we've got the video IDs we need. We can now go and fetch the actual data on the videos. So that will look something like this. Switch the fetch playlist items thing into a fetch videos thing. Instead of the YouTube playlist ID, we'll need the video ID. And then we will log that out to the screen. I am going to be a bit naughty. I'm going to copy and paste some code and we'll refactor it in a bit. So let me just duplicate that and change playlist items. Playlist item to video. And then I'm going to duplicate the page fetcher similarly. And let's see, videos page, YouTube, take the video ID instead. Playlist items becomes videos in the REST API. The playlist ID becomes just an ID. You can check the docs for that. Let's see what happens if we do that. Video ID is not defined. That's true, I need to pull that out. So the video ID is coming from the video playlist items content details. What was it called? Video ID. Let's try that. Yeah, again, something convincing. And again, we're not asking for the right kind of stuff from the API. The part we want, instead of content details, is we want the snippet, which gives us information about the video item's title, stuff like that. And we want the statistics, which will be the like count, the comment count, stuff like that. So if I run that, that's a bit confusing to read. Let's pretty print that. P format, the video, and I think I'll need to import that. Yes. Okay. There you go. That's what we're looking for. We've got the statistics there, we've got the title there, and we've got the ID that we're going to need to keep hold of there. Why don't we summarize that? Let's say summarize video is a new function which will just pull all the interesting stuff out for us. So we're going to return a new dictionary. It will have a video ID key, which is the video's ID field from Google. It will have a title, which is going to come from the video's snippet title. Let's just double check that. Statistics counts I'm going to want in a second. Yeah, a bit more convincing. Let's say the views are the video's statistics view count. And then view turns to like, and like turns to comment. That's about right. Let's see what that does. Ooh, not everything has a like count. Okay. We have solved this before, so and get like that. Change that to that one, and let's make it a default of 0. How's that look? Yeah, almost right. The numbers are all strings, so let's parse those. I think the reason that they're all strings is Google's worried about the numbers overflowing in JavaScript, which is a fair worry. Don't think we've got the same worry in Python, so that's the data we need. That's what we're hoping for. Time to stream it up to the cloud, I think. Let's go and set up a Kafka instance. I'm going to run my Kafka instance on Confluent Cloud, which is our fully managed Kafka service. You'll find it at confluent.cloud. You can sign up very quickly and easily, but I've already got an account. Surprise, surprise. If you do sign up, then head to the billing and payment section and add the code codinginmotion200, and you'll get $200 of extra free credit. At least you will while stocks last. Check the description if that code's expired sometime in the future. So, I'm going to set up a new cluster for this. So let me click there and call it Watcher. Create a cluster on my own. I'm going to use a basic free one. I'm going to take all the defaults. The only thing I'll change is to find somewhere that's physically near me. London. There we go. Single availability zone. Good. Cluster name, I will also call that Watcher. Defaults are fine. That will take a moment to spin up, a couple of minutes. I think it's running a Kubernetes job in the background. Pretty much everything is these days. I'm also going to set up a schema registry, which is a place that stores the type definitions for the data you're storing. Having a schema registry isn't actually mandatory, it's optional, but I like types and I will argue to death that it's a good idea to set one up. Again, I'm just going to pick a region near me and spin that up. It'll take a few minutes to run. And last thing, I want to set ksql running because I like SQL. I think it's a nice way to do stream processing. So again, I'm going to run through the defaults. I will call that Watcher ksql. Cluster size to 1. This is not going to be a high load application. I'll launch that. Again, just a couple of minutes of Kubernetes jobs running. So that's up and running. And that's also our special effects budget blown. Yeah, that was our upper limit of movie magic. Oh well. Okay, so let's click into that. And I need a place where I can store these packets of data about the video. Store my statistics. So I'm going to call it, let's say create stream YouTube videos. And it's going to keep the video ID, which is a varchar, or a string, as its key. And then we'll keep the title, also a varchar. Views can be an integer. Comments, also an integer. Likes, integer. This can really take whatever shape of data you are working with. It's fairly easy to define. It needs a couple of options, or I'd like to specify a couple of options. I want to specify the name of the underlying topic, the underlying logical chunk of disk we're using. It will create a default, but I like to specify it. So I'm going to say our Kafka topic is called same name, YouTube videos. I'm going to specify the number of partitions. I don't think this project actually needs sharding and partitioning. It's really not that heavyweight, so I'm just going to say 1. The key format is just going to be a plain string. The value format, how am I encoding those other value fields, the non-key fields? I like to go with kind of the de facto default, which is Avro. I could have chosen JSON, I could have chosen protocol buffers. I like Avro, that's what I usually use, so I'll stick with that. If I run that, I have a place to store this data. Cool. Time to get Python to start writing it into there. That will need a couple of Python libraries. So let's do pip install my favorite Python Kafka library, Confluent_Kafka. And just to make sure we can do the Avro encoding, let's pip install fast Avro. Is there a slow Avro encoder? I assume there's a medium speed Avro encoder, but I'm going to use the fast one. So with those libraries in place, we're now in the taking my data and writing it to a data store part of the code. That should be pretty straightforward once you know how. There's not much complex coding, but there is a bit of configuration to set up. The point I want to get to is I want a producer, a Kafka write-only connection, and I'm going to tell it to produce my video. That sounds way more Hollywood than it should. I want it to write my video data packet. So it's going to write it to a topic, and we've already decided that that topic is called YouTube videos. I'll specify the key, which is going to be the video ID. I'll specify the value, which I'm going to fill in soon, and I'm going to specify an on-delivery callback. That gets called because the production is asynchronous, so you want a handler to deal with any problems. So I will go up here and define it. I'm going to skip over that for now. The API is it gets an error, which may be none, and the record that it was trying to produce. And you say pass for now. So that looks pretty good. Auto formatting's a bit weird. If I put in a comma, auto formatting's a bit nicer. So I've got to define this producer. I've got to define this value. The producer object I need to use is called a serializing producer. It's going to encode my data as binary and ship it up to Kafka. So producer is a serializing producer. Give it a Kafka config, which I am going to define in my existing config file. What goes into that? What do you need to do to configure a Python connection to Kafka? Well, let's create a new Kafka key and we will fill this in. Like a lot of connection detail type stuff, this is a little bit boilerplatey. You look up the docs and you know it, but I'll run through it quickly. So you need to specify the bootstrap servers, which is what's the URL, what's the port. You need to say the security protocol, and for us that's going to be SASL over SSL. You need to say the SASL mechanism, and that is going to be plain because it's the SSL part that does the encryption. You need to specify a username, and that we're going to get from the web UI. Likewise, the password will come from the web UI. So it'll look something like that. You know what, while we're here, let's do the schema registry stuff too, because that's going to need a separate configuration and it's similar. URL, where can I find my schema registry? That we'll get from the web UI as well. And what is the basic auth user info, which is a long-winded way of saying what's your username and password for schema registry. That should do it. So let's write that. And that gives us 5 holes we need to go to the Cloud UI and fill in the details for. Right, let's get these values. Cluster overview, cluster settings, endpoints, Bootstrap server right there. So that goes there, Bootstrap servers. Username and password, data integration, API keys, add a key. You can do fine-grained access control stuff here, but I'll just go with global for this project. And copy the key as the username. And copy the secret as the password. Let's give it a name, Watcher. That'll do. Obviously, I'm going to rotate these keys before the YouTube file gets published, so don't try and copy them. They won't work. Then, schema registry down there. Let's see. API endpoint is the URL. Ooh. So that goes in there. The reason these names are slightly different is different libraries have slightly different namings. The Python ones are a little bit unusual. Then API credentials, create key, copy. And another thing that's slightly unusual about the Python library and some of the libraries based on the C library is the username and password should be username : password. Small gotcha, I think. So I'll give that a name too. And with that, we should be configured. So it's time to go over to Python and test it, make sure it works. Last bit of Python then. So I've got a serializing producer which should be configured correctly, except I need to tell it about the serialization format for these specific records. So I'm going to mix into that static config some instructions about key serializers and value serialization. The key serializer, well, the key is just a string, so that's a really easy thing to sort out. We just use a string serializer, like that. The value is more structured object. It's going to be in Avro format, so I need to use an Avro serializer there, and that's going to be a little bit more involved to configure. It takes two arguments, the schema registry client, where it can connect to and get schema-related details, and the schema string. That's going to be an Avro formatted string describing the schema. Let's get both of those sorted out. So, schema registry client is a schema registry client, and that takes the config that we already set up. Schema registry. Yeah, like that. Let's do the import dance now. That's coming from there. That's coming from there. That's coming from there, and that's coming from there. Yeah. Okay. Then we take this schema registry client and we say, hey, get me the latest version of the YouTube videos value schema. And that will give me a YouTube videos value schema. Yeah. Then that's the object we can look into to get this schema string. It will be inside a .schema string thing. Commas for auto formatting. So the key serializer is just a string serializer. The value serializer goes off to a schema registry and gets the details from there. That should be about right. Last haul, I think at the end of this I should make sure, before we exit the program, we should make sure that the producer has finished writing everything. So I'll add a producer.flush there. And then this value is the last sticking point. I've almost got this set up actually, because I've got, this is very similar to what I actually want. So let me just yank that out and put it in there. The only difference is the video ID is up here, so I don't put that in. And the field names will be uppercased. So that's going to look like the Avro formatted payload. I could refactor this, probably refactor it off camera. You can figure out how that's going to go. I think that's about the right shape. Should we see if it works? Let's see if it works. It's not blowing up. That's good. Let's go and check the web UI and see if it's actually streaming in. So we'll do that with an SQL query. Let's go back to our ksql prompt and say select star from YouTube videos. But we don't want to select once, we want like a long-lived running query. So if we say emit changes, this will keep watching for new data. And then if I go back to my Python script, maybe push it back up here, if I run that, it will go to YouTube, gather the data, it should stream it up to Kafka now, and we'll see a few seconds later it drops in here. That's exactly what I'm hoping to see. Let's check the numbers, views 2702, views 2702. So it's the same data. This is working. So we now have a Python thing that can gather the data we're interested in and stream it into Kafka. What we need to do is deploy this and run it on a schedule, so it's grabbing data every 10 minutes or whenever. But so that gives us a sampling rate, like a snapshot gatherer. Now we want to move over into ksql and do some processing on that stream of incoming data and look for changes. And this is where the SQL gets kind of interesting. Right, we need some kind of process that's going to be able to watch for this stream of snapshots and check for changes. Something that can say, for that video ID, you've just told me there are 20 comments, but the previous value was 19 comments, so you probably want to react to that change. And we can do that like this. We can say, create a table called YouTube changes as select the video ID from YouTube videos. We're doing the video ID first because that's going to be our group by key. We're considering each video in isolation. Then, if we say, how do we get the current value and the previous value for a given field? We can say, get the latest by offset of the comments. Give me the latest too, so that will be the previous one and the current one. And then we can index into that and say, okay, the first one will be the comments previous. And then we copy and paste that. And the second one is going to be comments current. Yeah, so those are my fields. It would be nice to get the title in there, but we're not going to group by it. So I'll just say latest by offset title as title. That looks all right. Then I am going to copy and paste that. Now I am in, I know I'm in a group of one here, or maybe a very small group, but I wish this editor supported Vim style editing so I could just search and replace all these fields transparently. But until that day, until that very, very niche feature gets put in, I'll do it the slow way, but might as well gather all these fields in one place. So that looks like all the changes. And one other thing, I think I will specify the underlying Kafka topic with an explicit name, the same as the table. I've always found it strange in SQL that it's 1 indexed instead of 0 indexed, but it is. That's the SQL spec, so ksql follows this too. So the first element will be the previous value, and the second element, the last element, will be the latest value. So if we run that, and I'm missing a semicolon, rerun that, that's created. Now if I say select star from, we'll just check this is working, YouTube changes, where likes previous is not equal to likes current. And if you could watch that for changes, keep that query running for me so we see any changes that come up. Now I will go back to my process, run it once. And then, can you like one of my videos for me?
You want to like one of your own videos?
No, that would be weird. That's why I'm asking you to do it. Okay, fair enough. 1 second. Done. Thanks. Now, if I rerun that process, I should now get a different value for the number of likes on that video. And over here, that should pop up right there. Yes, likes previous 56, likes current 57. So this is working. We've got a structure that tracks changes. So that brings us to the final piece of this. We've captured the data, we're storing it somewhere we can detect changes to it in real time. Now we need to find somewhere to send an alert message. There are lots of options for this, of course, and your mileage may vary, but the one I'm going to do is I'm going to use a Telegram bot. Assuming you've got a Telegram account, then you need to speak to the bot father. Start a new chat, and then you just say new bot. Alright, new bot. What are we going to call it? I will call it the Coding in Motion Alert bot. You need to give it a unique username. So how about Coding in Motion Alert bot in snake case? Okay, that gives us an access token. Obviously I'm going to revoke this before the video is published, but let's take a copy of that. So let's start a chat with that bot. Coding in Motion Alert bot. Start. Okay, so the last bit of data I need is the ID of this chat. There are a few ways to get it. The way I'm going to do it is to go over here and say curl https://api.telegram.org/bot, followed by that token we've got, followed by get updates. And that, actually if I pipe it into JQ, you'll see it more clearly. That has a chat ID just there, and it's that I'm going to need to send messages to that specific chat. That should be everything we need on the Telegram side. Back to KSQL, and we will actually start sending things there. We need a sort of outbox in Kafka, some place where we can store messages that ought to go to Telegram. So the ideal way to set that up is to create a stream called Telegram Outbox. And what this is going to have is one event in it for every message we'd like to send. And the shape of this is going to match the shape that Telegram's expecting. They want us to send a JSON object with a chat ID field, which is a string, and a text field, which is also a string. So I want to mirror this as closely as possible. And what's going to happen is every time we insert something into this stream, somehow a process will pick that up and send it as a post request. So, usual bevy of options to set this up. My Kafka topic I will call Telegram Outbox. Partitions, I would like one, your mileage may vary, and value format should stay as Avro. Now, the one thing to watch with this is by default, these field names are going to get folded to uppercase. But if that happened, it wouldn't match the JSON payload that Telegram are expecting. So I'm going to force it to match my case. I'm going to break the convention and use back primes to say, when I say this case, I mean this case. So run that, and I should have a new stream set up like that. Now, about that process that's going to make the post requests. There is a mechanism for doing that in Kafka. It's called connectors, and they are great whenever you want to get data in to Kafka or out of Kafka in a way that probably someone else has already invented. So in this case, if I go to Data Integration Connectors and look for HTTP, there is an existing HTTP sync connector. That's all we need to make this request. And if we find the fully managed one and get started, we can run this all in the cloud. Let's look for the Telegram Outbox. We're going to connect it to the Telegram Outbox. We are going to give it a key, and we will say that's the Telegram connector, just to describe it for later. Okay, the configuration for this. The URL is HTTPS. This is almost exactly the same as the one we just used at curl. api.telegram.org/bot, my token /send message. That is all you need on that page. Input record value format is Avro. A few advanced options. Request method, post. HTTP headers, I need to tell Telegram that my content type is application JSON. Let's see, what else have we got here? Request body format will have to be JSON because we're sending JSON payloads. By default, connectors try and be efficient and batch up your records into groups. That's not going to work here. We want to send one message for every event. So match back size 1, and because it tries to batch things up, it's going to by default try and stick messages into an array. So it's going to try and have an array of one thing at the moment. We don't want that. We need to unpack that array and just send the object. So batch JSON as array, false. That, I think, is all we need to do to set up a simple outbound HTTP connection. So let's run that. One task will be plenty for this. Let's give it a decent name. Telegram connector. Continue. That will take a few seconds to cook. Looks like that's cooked. So back here. And let's insert a test record into Telegram outbox. Again, with the back primes to match case, we will insert a chat ID and some text. And our values will be... Oh, my typing's way off. Values. The message ID is that. Sorry, the chat ID is that. That's the one we got from the curl command. And then the message can be nearly there. Because we really are nearly there. Run that, and let's see if we get an alert. Oh, I think my watch just pinged. Nearly there. Let's just double check that. Yes. Yes. Okay. Yep, that's definitely working. So I think that puts us 2 SQL statements away from the finished pipeline. Let's go and write a little bit more SQL. And the SQL we need is something that's going to bridge the gap between this table, which is grouping by video ID and letting us see the changes on a per video basis, and this stream which says if you stick something into this stream, it will go to Telegram. The way we can do that is by recognizing that a table in Kafka land has an underlying topic, and topics can always be read as streams of events. So when the table makes a change, it writes it to the topic, and the topic can be seen as something we can stream out of. So we can kind of subscribe to table changes, which is cool and useful in a myriad of ways, but let's focus on the one at hand. Let's create a new stream called YouTube Changes Stream. But this stream doesn't create its own data, it borrows from someone else's data with the Kafka topic of the same topic as the table. So the table is going to worry about creating the data, and this stream is just a logical view over it to look at the table as a series of table change events. It's probably easier to describe in code than it is in words. Value format, as ever for me, is going to be Avro. And that should create us a new stream. Let's have a look at our streams. YouTube Changes Stream has the same value fields, so that's something we can work with. So, now it's easy. We've got a stream of table change events and a stream of outbox messages. We just need to bridge the gap, and we can do that with an insert select. So let's do that. Insert into Telegram outbox as select that magic value as my chat ID, and how about likes changed exclamation mark as my text from my newly created stream, YouTube Changes Stream, where likes current is different to likes previous. That would be about right. Let's do a slightly nicer string. Let's concatenate some do some string munging in SQL. Something like this. Likes changed, colon, likes previous to, let's do a little arrow glyph, likes current, full stop, and then we'll do the title. Yeah, that'll do. That'll look nice, I think. Let's run that. The as is incorrect. That's the wrong syntax. Concat string integer string. This is casting. I need to cast those two integers as strings. String. As string. Ba-da-da. There we go. Let's see if it likes that. It seems to like it. Okay, let's run this one more time. And then if you could like another video for me.
Sure thing. Done.
Thank you. And then we'll run that again. That data should go up into Kafka, be detected by our queries, shoved into the Telegram outbox thing, and the connector should then send that to Telegram. And with a bit of luck, there it is. Likes changed. Is that the one you liked?
Well, I like them all, but that's the one I just clicked like on.
Perfect. Okay, that's it. We've built an end-to-end data processing pipeline. Should we do a wrap-up summary?
A post-mortem?
A retrospective.
A retrospective. I like that. Okay, break it down for me.
What did we build?
We've built a data processing pipeline. We've got a Python script searching the web for information we're interested in. In this case, the YouTube API, but I think it could be nearly any API. And then once it's got that data, once it's got a snapshot of the state of the world, it sticks it into a Kafka stream. We do some stream processing to look for changes, and then when the changes are interesting enough, we ship it out via a Kafka Connect connector to Telegram. But again, it could be almost any alerting system. I think you'll see this is a fairly generically useful pipeline that happens to scratch a particular itch I've been having.
What would you change about it?
Yes, always an important question in software. What could we improve? I can think of a few things. You remember we copy and pasted all that paging code? I think I know a good way to refactor that using higher order functions, and I think that would be interesting. But I think we'll have to leave it for a refactoring follow-up video. So maybe leave a comment below if you're interested in seeing one of those. There are also some tricks and tips I've got that I think would speed up the way we query YouTube's API, a couple of optimizations we could do there. And the last one is deployment. The quick high-level summary is create a Docker file, find one of those services that will host your Docker container for you. That's the way I'd do it. But if we do a refactoring video, I'll take you step by step through that. The point is we need to deploy this somewhere that will run independently of us and probably on a every 10-minute schedule. And yeah, that would pretty much do it, I think.
Where are you going to take it next?
Oh, that's easy. I think what I'm going to do is get an HTML parsing library, and then I can query some of my favorite online shops to see if the price of certain synthesizers suddenly drops. That'll be my second pipeline going into the same Telegram outbox, and maybe I'll grab a bargain. But in the meantime, I think that's all for this video. If you've enjoyed it, please leave a comment down below. If you'd like to see the refactoring deployment video, leave a comment about that. If you click like, as I hope you will do, rest assured that I'll be getting a notification about it moments later. But for now, that's all from me.
And that's all from him. Till next time.